Hello friends, in the following video presentation I'm going to show you how you can make use of OpenCV for handling images within Python. And OpenCV is a very important library for image processing as well as image manipulation, and you will be getting some hands-on experience about these things in the following video. So certain packages we need to add. We have to make use of NumPy for our ND array. We need to make use of OpenCV, CV2. For displaying the image in a graph format, we will make use of matplotlib.pyplot, and we have to embed the image within the Jupyter notebook, so we have gone for inline. So here I have got a file called cat.jpg. So let me show you the file cat.jpg. So as I move backward, over here I have a data, and inside the data I have got a file called cat.jpg. So I'm going to work on this particular file, and let me remove this file. Yeah. So let's come and check it out. So I have a folder called data, and within that I have got a cat.jpg. So I'm going to read that image, okay, with the help of CV2. So CV2 dot image read is a function which takes the parameter as a path where the image file is present, and it creates an instance, and I've given the name of the instance at img. So let me run the file, run the statement, and yes, I did. So what is the outcome of this particular instance? So if you want to check, it's actually in the form of a numpy array, and that's the reason why we made use of np represents numpy array. So once we have read the image, we actually get the data in the form of an array. So what exactly is there inside this image? Would you love to see that? So let me uncomment the following line, and as I hit enter, you will find over here a list of array with numeric values are present, and this is what actually is the image representation within the system's hard disk. So your whole image has been generated in the form of an array, and that's what we have been stored over here. So if you wish to even you can check out its shape also. So over here I have got an attribute called shape. So let me show you the shape as well. SHAPE shape, and it is of shape of number of rows and number of columns. Is it's This is the width and the height of the array, and it has got three channels. The three channels represent the RGB. Okay, so that's the width of the image, and that's the height of the image, and this width and height we will be able to see when we will go for plotting of this image. So let's go and plot the image. So let me uncomment the following line, and let me hit enter. And if I do that, if you see over here minutely, the width was 400. That's the reason the 400 is mentioned over here. So this is the from 0 to 400 is a width, and 272 is the height. So if you go by the y-axis, so this is around 272. Okay, and it has got three channels. That's the reason you are seeing it in a colored format. But obviously this is not the original color of the image is. Okay, actually why this color has taken place, because there is some reason. Do remember, we have read the image with the help of OpenCV, and we are plotting the image with the help of matplotlib. So what matplotlib is expecting? So let's come over here. The image has been correctly loaded by OpenCV as a numpy array, which we also saw, but the color of each pixel has been sorted as BGR. So whenever CV2 is reading an image, the image will be in the form, the image read by this OpenCV would be in the form of a BGR, blue, green, and red. Whereas matplotlib is expecting RGB. So that's the reason there is a distortion. Okay, CV2 has read the image in the form of BGR, and matplotlib is expecting RGB. Hence, we need to swap these channels, and for that purpose, CV2 has provided us a very nice function that is called cv2.convertImColor. So over here, we just went for cv2.imread, and now we are going for cv2.convertColor, where we are passing the instance, and we are also passing the flag that refers that which particular color format would you love to go for. So initially it is in BGR, and we are going to convert it to RGB, and the instance we are going to store it right inside this particular variable, image underscore RGB, and then we are printing it back with the matplotlib. So let me fire this particular statement, and now we will see the actual image of the cat. So initially, keep it in mind, when OpenCV would be reading the data in the form of image file, it will be in the form of BGR. So if you want to see the proper color format, then we have to go for the conversion, and then we will be able to see it in the right format. And with the help of matplotlib, we are getting a graphical representation of the image in the form of an x and y coordinate. Okay, so this is what the image is in the colored form. But what if I want in a monochrome form? So that means in the form of a black and white or a grayscale. That also has been very easily available. Over here I have got another flag variable image read underscore grayscale. But if we do read directly like grayscale, then there will be a slight distortion once again, because directly you are converting your BGR to grayscale. This form of distortion would be taking place. To resolve this distortion, OpenCV has got another flag variable, that is the color map, CMap, and here if you mention the parameter would be gray, then you are going to get exactly the grayscale. Okay, so over here if you see, this is how the grayscale got generated. So initially the first parameter, the first statement remains exactly the same. You are reading the image in the form of BGR by CV2, and then you are converting grayscale, but exactly the grayscale it won't take until and unless you go for the second parameter, that is a color map, and here we are specifying the grayscale. So once you do that, then your image is going to be in a grayscale. So remember, this was the actual image, and now after converting it to grayscale, you are getting this. So you might have a plan that you will be saving this particular grayscale as a new file, okay, so that you might be in need of this grayscale for some purpose. So how do you save this particular file which OpenCV has generated? And for that reason, we are coming to the next set of instruction where we will see how do we save a file. And before we go for this particular statement, let me show you the current location where my file OpenCV, we are working in the NumPy OpenCV file this is, and we don't have any other PNG or JPG image. But if you see over here, what I have done is that this is my grayscale instance, image underscore gray, and I want to create one new file by the name of new underscore gray.jpg, and I'm using a function called I am write. So I am read is the function to read the image, and I am write is the function to write the image. And after writing the newly created image, I want that I will be able to read that image. So I can go for reading the image like this, that is also possible, or I can directly work on the previous instance. So here what I am doing is that I am reading the new image. So let me just copy the file name, and I'm just changing the file name over here. So I'm reading the image in a grayscale mode, although it's in a grayscale mode, so I can just go for image read only. So I don't need this particular parameter in that case, because it's already a grayscale, and then I'm putting it over here, and then I'm going to fire this line. Okay, that's really good. So what I can do is that let me just try it once again. Let me put a command line over here, and let me remove this particular file. Yes, the file is no more, and let me get back over. Let me get back over here, and let me run the file once again, and it's true. That means the file and its content got created. Yeah, 23 KB. So it's working now. So once we have done this, then we can go for, I insert a new cell below. So what I can do is that I can read this image. So I'm reading this image from here. So let me get back to this. I'm reading this image. So the newly created image is called new image.jpg. So let me remove this path, and I put it over here. New image.jpg. I have read it, and now I want to go for plt img. So plt. So let me just copy the statement, and let me write the statement img first bracket, and let me fire it. Yeah, now it is working pretty smooth. So we have created the new image file, and then we have displayed it successfully. So there was some internal issue. At times these things do take place depending upon your system configuration, and my hard disk actually almost filled up with a lot of data. So that's the reason there might be some issue. Otherwise the thing got sorted out. So after creating a new grayscale image, you save the image, and we saw there is a boolean results. Will be true means that the image file got created, and there is a proper data as well. If it is a false, then the file will be created, but there won't be any data. Okay, that's what you have to be very careful about. Okay, just see the output over here. So once we have saved the file, we already opened the grayscale image with that what we did. But if we want to open the grayscale image in a bit different way, what different I want? Over here, the file is shown in a workspace of this much width. But what if I want to see the same image in a larger workspace, and that brings us to a couple of functions that matplotlib will provide us. What is the function? The function is called figure, and here we are mentioning the figure size in the form of width and height. So what should be the width and what should be the height? I'm mentioning the width and height over here, and I'm creating instance variable in the form of figure. I'm adding a subplot over here, and over here 3 parameters are added up. This is a very important part. What these 3 parameters represent is we want that there should be one row, there should be one column. So one row, one column, and in that one row, one column, there should be only one image. That is what I want. Okay, and I am working on the new grayscale. So I have this particular instance variable img. So what I can do is that for the time being, I'm not using the color map. Rather, I'm just chopping it out, and instead of that, I am using the img. Let's see what happens over here. Yeah, it is working pretty good. And see, the image which was this much size is now comparatively larger in size. Okay, and I have written over here 1 comma 1 comma 1, so one row, one column, and one image. Okay, so if you want that, if you yeah, by the way, if you want to increase the size of the workspace, so you can do that. The width and height I increase, so let me just go for it, and yes, comparatively much larger. And now if you want to see the what is the role of this 1 comma 1 comma 1. So suppose I want to go for 2 row by 2 columns, so I'm writing 2 over here, I'm writing 2. So there will be 2 row and 2 column. Currently right now I'm seeing the only one image. So if I fire this, the workspace is much larger, but it has adjusted its width according to 2 row, and this is the first row, first column, and the only one image is there. So what I can now do is that I can copy this and I can paste it once again, and here I will still return there will be 2 rows and 2 column, and this is my second image. And if I do that, you will be finding another image right beside this. Isn't that cool enough? So you can again copy this statement and you can rewrite it. Remember, whatever your width and height would be, that depends upon the figure size. And over here I'm going for the third figure, so I hit the enter and it will be right below this. So that's how the 2 row, 2 column, and the third parameter is getting regulated. Okay, that's how the image are being plotted. And so if you want to go for one more time, that also you can do it, and this would be the fourth image. So ultimately you got all the 4 images side by side. This is how the matplotlib is going to work so nicely, and this whole size is what you have generated in the form of this particular figure size. So now it's up to you that you can generate a single size image, or like a single size means I just comment the I'm copying this single statement and I'm commenting this all this following statement. And if you just want to go for one size, that also you can do it by writing just a minute, wait an hour. Over here I can go for 1 comma 1, and then you get to see the entire larger image. Okay, so that's how the thing can be sorted out. So this is how you can open the image in a much larger screen. Okay, over here you have, now we go for the image resize. If you want that, you can resize your image. We already seen the size, so this is the size of the image of in the form of, so over here we have got width and the height, sorry, this is the height and this is the width and number of color channels. Okay, there are 3 color channels, BGR or RGB, whatever you call it. If you want, you can reduce the width or increase the width. So what I have done over here is, let me just execute this and let me remove the command line over here. You will see the thing what I have done. So 1300, if you see, I have made the width of 1300 and the height is 275. So you can even write your new file by saving this particular img. I am right. You can save this particular instance, which will be again your image will be of different size. That also you can do it. Okay. So the last portion is about flipping. You can flip the image over here. What we have done, let me show you. You can flip the image on x axis. So if you do that, then the image gets flipped in the x pattern. So there will be slide. If you see the okay, let me show the y axis also. Then you will be able to differentiate what the thing is. So see over here, this image has been shifted slightly toward the right side, and this image is shifted slightly toward. This is actually the it has been shifted to the left side. Okay, so this is how the flipping is taking place at the same time, it has just gone upside down as well. And if you want to retain the original axis, then you can go for -1. So you have got three different parameters. If you have to go for x, then you will go for 0. If you want to go for y, then you will go for 1. And if you want to retain the actual image, or if you want to retain both the axes, then you will go for -1. So finally, in this particular video presentation, we have seen that how we can handle image, how we can write a new image file, how we can convert the color to grayscale and resize and flip. All these things we have seen it, and I'm very sure that this thing will be very helpful to you people. In my coming video, I will be doing something very fascinating. That is, I will try to merge two separate image file, and I will try to create one image file, and that image will be an output of both the combination of both the files together. So I believe that that video, or the upcoming video, will be really great help for you guys. So stay tuned with my channel and just keep on watching. If you have got any suggestion, please do put forward those suggestions. I will surely work on them, and just wait for my next video. Until then, have a nice time.